So this is NCBM 0142, linear inequalities. Rules to consider when following linear inequalities. Solve the inequality as a regular linear equation. Always leave your isolated variable on the left when solving the linear inequality, and you divide by a negative constant to change the inequality. So we have negative 4x minus 7 is greater than 5. So before we continue, remember that this is greater than. This is less than. And these in the number line will be represented with parentheses because they don't have an equal sign. However, these, which is less than and equal to, this is greater than or equal to, will be represented with brackets because they are part of the answer. So in this one, since we don't have an equal sign, we'll be using parentheses. So we have negative 4x minus 7 is greater than 5, plus 7 to both sides. That cancels. We have negative 4x is greater than 8, 9, 10, 11, 12. Divide by negative 4 on both sides. So now we're going to have that x is less than negative 3. Why did the inequality change? Because of we divided by a negative constant across it. So we have to change the direction. So now we're going to do a number line. Let's put that as a blue. And we have our 0 right there. And we have our negative 3 right there. And since this, it's pointing towards the negative infinity, we're going to be shading this guy going this way. So therefore, our solutions for this to be true is from negative infinity all the way to negative 3. We can check this by using numbers. If you forget to leave x by itself on the left, how you can check this is by using numbers. So let's say I use negative 10 to test, and I use 0 to test. One's going to represent, oh, by the way. So we have negative 4 times negative 10 minus 7 is greater than 5. So that's going to give me 40 minus 7 is greater than 5. 40 minus 7 is going to give me 33, which is greater than 5. So this is the way we're supposed to shade it. Let's see on the test with 0. So I have negative 4 times 0 minus 7 is greater than 5. So this cancels. So this is false. So that's why we don't shade on that side. Negative 2x plus 8 greater than 4 minus 8 to both sides. So negative 2x is less than negative 4 divided by negative 2. Since we divided by negative 2, the inequality will have to change. Now we have greater than 8. So we have 0, 8. So according to our shading, we're going to be using, or to our equation, we're still going to be using parentheses. And we're going to have to shade. It's pointing towards positive infinity. So my solution for this one is from 8 to positive infinity. Let's see if this is true. So I'm going to test with 0. So I have negative 2 times 0 plus 8. So I have, so is 8 less than 4? This is false. So that's why I don't shade on towards negative infinity. So let's test with, I don't know, let's say 10. Test with 10. So I have negative 2 times 10 plus 8. So that's going to give me is less than 4. So that's going to give me negative 20 plus 8 less than 4. Negative 16 is less than 4. This is true. And that's why you shade towards the infinity, positive infinity side. Again, you're just solving as a regular linear equation. So I have this, so I'm going to distribute that 4. So I have 3 minus y is less than or equal to 4y minus 12 minus 4y. I'm sending it the 4 to the left to leave the y on the left by itself. So I have 3 minus 5y less than negative 12 divided by negative 3. We have negative 5y less than negative 15 divided by negative 5. So we have y is greater than 3. So y is in the left, and it's pointing towards positive infinity. So my solution is from 3 to positive infinity. If we're going to graph this, this will become 0, 3. Sorry, this will not be a parentheses. This is going to be a bracket, and it's going to go this way. So that means that I have to correct this, and this is a bracket 2. Notice how infinity stays with a parentheses. That's because we don't know. Infinity is a concept, not a number. We don't know where it's going to end, thus we can't make it a bracket. So now we have, distribute that 2. X minus 2 is greater than or equal to 2x minus 10 minus 2x to both sides. So I have negative x minus 2 is greater than negative 10 plus 2 to both sides. So negative x is greater than negative 8 divided by negative 1. Then I have x. I almost did the mistake that I told not to do. Positive 8. So this is showing me that my solution is from negative infinity all the way to 8. But this is a bracket. So I have 0, 8, and 10 to test. So according to our equation, we're going to be going with a bracket. And solutions are that way. Okay, let's do our test. A test with 0. So I have 0 minus 2 is less than 2 times 0 minus 5. Sorry, greater than. So we have negative 2, 0 minus 10. And this is true. So, true. In this problem, I'm going to be separating this thing. So we have 2 less than or equal to 3x minus 7. And then I have 3x minus 7 is less than 14. I'm going to solve the same way, leaving x in the left. So I have negative 3x plus 2 is less than or equal to negative 7 minus 2 to both sides. Negative 3x less than or equal to negative 9 divided by negative 3 on both sides. Since I divided by a -3, I must change the direction of the inequality. Then same thing, plus 7 to both sides. 3x is less than 21, so divide by 3 on both sides. So x is less than 7. So therefore I have that on this one, x is greater than or equal to 3. And I have that x is less than 7. If we do a number line, this is going to be our 3. This is going to be our 7. Our 7 is pointing towards negative infinity. So technically this is 2, 7. And this is pointing towards positive infinity. So this would be from, okay? But notice that on the left, notice that on this side here, this statement is not true for the 3. Likewise, from here to positive infinity, the statement will not be true for the 7. So our true answer is the shade in between, because that's the only place where both are true. So therefore our solution is from 3, remember bracket because of the equal sign, all the way to 7. So that would be our range of answers. So on this one, we have that -7 is less than 2p minus 3. And I have 2p minus 3 is less than or equal to 5. Solved like we did on the previous problem. So I have -2p minus 7 is less than -3. Plus 7 to both sides. -2p less than 4. Divide by -2 on both sides. Since I'm dividing by a negative, I must change the direction of the inequality. So it was less than before, now it's greater than. -2. Then plus 3. 2p less than or equal to 8. Divide by 2. So p is less than or equal to 4. Like before, let's do a number line to see how this looks like. We have a -2. We have a 4. The -2 is pointing towards positive infinity. The 4 is pointing towards negative infinity. So like before, our answer will be within the middle of the range because this is the only place where they're both true. So I have